Hi, today we're going to have fun with reed switches. We're going to use a pair of reed switches to give speed and direction to any toy train. This train here was made in the 1950s, and we got a couple of reed switches connected to our Arduino, reporting through Bluetooth to an Android tablet, and that's going to display our speed and direction. Here's our New York Central F3 heading back the other way, and then we'll go over and take a look and see at the tablet. Underneath the picture of the F3 is the speed at which it just passed across those two sensors, and down below it says heading towards city. That's an indication of direction that I used on this layout. But this video is about the construction of the reed switches, and you'll see the train's going to come back. And when it comes back, that speed is going to change to in the 20s, I think. It'll go a little slower. Yeah, there you go, 25 miles an hour. So in any event, this video is about the creation of the reed switch sensors and connecting them to an Arduino and reading them and then calculating speed and direction. So we start with a little circuit board, and we cut it up into little pieces. Really small pieces, as you'll see as I cut through it here. This circuit board also breaks really easy. I could have just put it in a vise and cut it, but since I wanted such small pieces and smooth ends, I cut and sanded the ends. And now we're going to wire the reed sensors and wires to the circuit board. And that's the reed sensor, that little black thing. I'm just bending the leads. We're going to stick it through there, and then we're going to put that in our soldering vise and solder it all up. Be careful it's sitting flat. Iron's hot, solder's good. We're going to do this joint. It didn't look quite right. No, not quite. A little more. There we go. Do the other one. Get the wire. By pulling that wire around, it made the lead come out more perpendicular to the board. And there you go. So that's a complete sensor. All it is the switch and two wires. And I have it connected up to the voltmeter just to test it with those magnetized wheels. I also have little magnets I put on trains without magnetized wheels, so that's how that's going to work. The magnet flips the switch, closes the switch. Now we're just going to connect those wires to our Arduino. This end we're going to glue to one of the ties on the track. Yep, just simple Elmer's glue, and away we go. We'll connect that up to the Arduino and write a little program that will read the switch. Basically, we're looking just for the switch to get closed. And there's a little debounce in there to tell us that the switch is closed, and we'll call that a detection. The bounce has to be pretty big because the wheels on this train are magnetized, and so they flip it several times, plus the switch will bounce. And there it is, detecting the train as it passed by two of those sensors I installed. I'm going to measure the distance. You notice I put some tape on to just hold them in place while the glue sets, but otherwise that tape will come off. But I'm going to measure that in millimeters and then enter that number into my program, where then I can calculate speed. I know the direction by the order in which the switches are flipped in time. So 385 millimeters, there we go. And load that onto the Arduino after making that change. And then we'll test it with speed. So we're just going to calculate the time it takes to go between two switches. In this case, the reed switches, which are closed by the train passing overhead. So here you go, at 31 miles an hour in the reverse direction. And the train will go around the track, and it will try the other track. And I got another train going. So there we are. That's the track 1. Here comes track 2 in this example. And we've got track 1 speed 28 and track 2 speed, I think that was 43. I didn't linger on it very long. But you get the idea. So just a simple switch. Didn't need really any other components. The Arduino has a built-in pull-up resistor, so I don't even need to add that. Just connect to an input pin and ground. Now, I used a pin change interrupt to detect when the pin was closed. And the pin change interrupt is pretty straightforward. You can look that up. But just know that that's fired in groups. So you've got your interrupt has to handle, in my case, both all 4 switches. And there's the pin chains at the bottom. That's all there is to it.